So here's another example now, okay? So this one, again, it's similar. Originally, I was going to have people work on this, not to hand in, of course, but to practice, but I really want to get through it, so let's just do it together. So this one's actually very similar, except the numbers are different. In this case, we want to have $800,000 in retirement, in 30 years. So we want to have that much in 30 years. And in this case, the account is earning 6% interest. Well, again, we're going to make monthly deposits, right? We're making deposits, right? And they're asking us, how much would we need to deposit in the account each month? So we're making monthly deposits. Notice also that implies, well, for one thing, we have many deposits, not just one. So we have an annuity. And, okay, not only that, we're assuming the account is being compounded monthly. Okay, it's being compounded monthly. Remember, unless stated otherwise, the account is compounded as often as we make deposits. Oh, sorry, there we go. I was pressing the wrong button. Here we go. So again, we're going to use that same formula. We have to figure out, though, what the variables are. So we have A is the balance, right? But we know what that balance is. We want it to be $800,000. We're looking for the regular deposit, right? How much we would have to deposit each month. So PMT is unknown. The annual interest rate, okay, right? That's given to us, 6%. For the formula, though, you have to convert it to a decimal. So it's 0.06. We said it's being compounded monthly, right? So in a year, 12 times. The number of years we're making deposits, right? How long is this going on for? We want to retire in 30 years. So we're making deposits for 30 years. So that's what we're doing. So that's what we're doing here. Okay. Then we have our formula. All the variables are in. We know what we have to figure out. It's just like before. Okay, let me keep going. So we have the formula just like before, right? What do? We have to use order of operations. The numerator and denominator, we work separately. So the denominator is easy, right? We just divide. The numerator, we have to work inside out, like so. Okay? We have, this quotient is just this, 1 plus this, as you can see, right? And now we have the exponent, which is 12 times 30, which is 360, right? So we're raising that to the 360. And what is that equal to? Again, we're doing order of operations. So we do this first, and what do we get? We get this number. This, again, I use the calculator. Okay? I mean, I can't do that power in my head. If you can, that's great. We have this, and now we're subtracting 1, and so on. So we're left with this here. We're almost there, right? Okay, good. And now, as you can see, I just reproduced this. We divide. Again, it's just like the previous problem, right? We divide, then we divide again, okay? And finally, we get which is equal to this quotient, okay? And that turns out to be about this. You know, again, I rounded, of course, so you would round to 2 decimal places. So we get about $796.40. Again, you know, I rounded. We do want to round to 2 decimal places in the end, but again, I do recommend using as many as you can. You know, I use what I use. I use 5. So the more you use, the more accurate your answer is going to be. The more closer to being the right answer. Okay, so we have that. Remember, part B. No, here it is. We want to know how much money in total will we put into the account? Well, it's just like before, right? How much are we contributing over the course of 30 years in total? That's going to come from our deposits, right? Monthly deposits. Well, if we're depositing this much each month, they're asking then, how much will you have contributed after 30 years? Well, we have this per month, right? We're going to multiply it by 12 months per year, right? Because we want to get 30 years. So we do that, and then we multiply by 30 years. Remember, you want to keep 12 there, right? Mostly because we have months and years. So the 12 months per year, you know, fixes this conversion difference, so to say, the unit difference. You know, it's just like the factor label method, 12 months per year, so we multiply by that. Then we multiply by 30 years, and we get this. So we end up contributing $286,704. But there's $800,000 in the account. Where'd the other money come from? Interest. So the rest of the money is from interest. Okay? So how do we get that? We subtract. Okay? That's how we get the interest. Okay, are there any questions on that? I hope I didn't go too fast. I don't think I did. We have 5 minutes. There's one problem left, this one. Let's see if, although I guess we could stop here actually, because I don't want to rush through this example. So you know what? Let's stop here, okay? And what we'll do is we'll start from here next time. So Thursday we'll do some more review. I'll probably just do more problems like this. Because again, my understanding is this stuff was really tricky for everyone. So, okay. So why don't we stop here, I guess.